So in today's lesson, I would like to talk about a resource-based economy. So in today's class, we will talk how this policy works in the future. So the Venus Project proposed that we work toward a worldwide resource-based economy, a holistic social and economic system in which the planetary resources are held as the common heritage of all the Earth's inhabitants. The current practice of rationing resources through monetary methods is irrelevant, counterproductive, and falls short of meeting humanity's needs. Simply stated, within a resource-based economy, we will utilize existing resources rather than money to providing an equitable method of distribution in the most humane and efficient manner. It is a system in which all goods and services are available to everyone without the use of money, credits, barter, or any other form of debt or servitude. How do we achieve this resource-based economy? So my answer is through technology. Many people believe that there is too much technology in the world today, and that technology is a major cause of our environmental pollution. This is not the case. It is the abuse and misuse of technology that should be our major concern. In a more human society, instead of machines displacing people, they would shorten the workday, increase the availability of goods and services, and lengthen vacation time. Our plan is to utilize new technologies to raise the standard of living for all people, hence the infusion of machine technology would no longer be a threat. Cybernating technology. Computers today replace human brains with electronic equipment that manipulates figures, makes programmed decisions, and gives instructions far more efficiently than any human. Cybernation is the linking of computers with automated systems. The central cybernated systems will coordinate all of the machinery and equipment that serve the entire city, the nation, and ultimately the world. One can think of this as an electronic autonomic nervous system extending into all areas of the social complex to ensure the efficient operation of the city's various functions. All of the processes and services are equipped with electronic environmental feedback sensors. These sensors are coordinated with redundant backup systems that operate in the event of failure or breakdown of the city's primary systems. So now we will talk about existing resources. Existing land and sea resources, physical equipment, and industrial plants will be utilized to enhance the lives of the total population. In an economy based on resources, we could easily produce all of the necessities of life and provide a high standard of living for all. So in the construction section, the construction of the new cities also involves methods significantly different from the ones used today. Fast and reliable construction techniques take advantage of prefabricated material extrusion and various alloys with memory characteristics. Most of the buildings are made are high in strength, light in weight, and resistant to foreign factors such as weather and insects. Materials with memory characteristics allow for design flexibility as well as intelligent resource utilization. Each of these solutions below are only examples of what could be done under high energy conditions if we use science and technology with human and environmental concern. Automated construction. A multifunction unit machine is used to lift and later insert prefabricated housing components into a support structure. Although these prefabricated units are composed of standard components, they are of a modular design with such a wide and diverse array as to allow maximum individual expression in interior design and decor. Automated cranes. Eventually, most of the construction of the industrial and research complexes in a circular city are carried out by robotic equipment that receives instructions via satellite, and automated cranes travel along the building's length, installing floors, windows, curtain walls, roofing, and other components from the ground up. These devices contain sensors to minimize industrial accidents or collisions with other devices or living beings. Laser excavators. A laser excavator directed via satellite is capable of fusing the earth beneath it into a molten magma-like material. This machine is able to change its shape to conform to a wide range of contours such as canals, roads, and waterways. Now I will talk about industrial robots. Multi-axis industrial robots utilize vast information resources which enable them to receive commands via satellite, uplink, or on-site. They are also designed to take appropriate actions in the absence of human directives by combining an array of sensors and receivers with sophisticated decision-making abilities. They are capable of handling a wide range of industrial production tasks and are able to upgrade their level of service and replace defective or worn parts. These mega robots communicate with one another to coordinate delivery of the required materials for each project. And the next section is nanotechnology. The future of nanotechnology offers enormous potential. Nanotechnology combines optics and lasers and will eventually enable us to assemble matter atom by atom into whatever molecular structure is needed. Nanotechnology will lead to a submicroscopic revolution in all fields, including the way in which we conduct human affairs. Cities in the sea, so how will they look in the future? A global network of such cities in the sea can easily accommodate many millions of people and relieve the land-based population pressures along with the threat of rising sea levels to islands and coastal areas. They can provide the inhabitants with information and serve as natural sea aquariums without artificially enclosing marine life. Many of these cities may serve as oceanographic universities that maintain the ecological balance of marine systems. Other ocean cities will maintain sea farms that will cultivate many forms of marine life. They could also be used as a new resource for mining the relatively untapped resources of the oceans without disturbing its ecology. Still others may monitor and maintain environmental equilibrium and reclaim dangerous radioactive, plastic, and other pollutant materials that have been dumped into the sea. After construction, these structures can be towed to various locations where they would be most beneficial, then anchored to the ocean floor. Some structures will be towed in prefabricated segments and then joined together at selected locations. Their internal construction will include flotation chambers which will render them practically unsinkable. They can be self-maintained and fully automated. Now, offshore living. How does it look? Offshore apartment buildings of concrete, steel, glass, titanium, and a wide variety of new synthetic materials could be built to relieve the population pressures in areas like Hong Kong, Tokyo, Los Angeles, and New York. The materials used in such projects would be engineered to withstand the corrosive effects of the harsh ocean environment. Now, mariculture and fish farming. Such systems would be used to cultivate and raise fish and other forms of marine life to help meet the nutritional needs of the world's people. Capable of cultivating a great variety of marine life, these structures would be equipped to permit the free flow of water throughout the system. They are designed to be a non-contaminating integral part of the marine environment. The next section is automated water systems. Eventually, with applied total design concepts and mega hydrological projects, we could minimize the threat of floods and droughts. These waterways would be an integrated part of a national flood control system that would hold back flood waters which could be released during periods of drought. And they are used to maintain the water table. It could also be used for irrigation, shipping passengers, and bulk freight. And the water storage basins could be used for recreation as well. In many instances, the waterway would be used as evaporative desalination. So this is it for today. As I have mentioned before, resource-based economy is part of the Venus Project, and the founder of the Venus Project is Jacques Fresco, who is the American scientist who lived between 1917 and 2017. In our next class, we will talk about the Venus Project. Goodbye. See you in our next class.